Hey guys, welcome. This is chapter 1, review video 2 for geometry. Let's get started. These problems are taken from your test, meaning I looked at the tests and then I'm creating problems that look like the questions on the test. So these are very important. Okay? Alright, number 1, name opposite rays. Lots of different answers in this problem. We want to make sure that we do something very important. Pick one endpoint. I'm going to pick C. Why not? And I'm going to make one go this way, and I'm going to make one go that way. All I have to do is start with C and then go towards D and make sure my arrow heads in that direction. The next one, I can still start with C and then do B, but make sure it heads in that direction. Don't be confused with the arrow going not in the opposite directions in my writing, as long as they go in opposite directions. Again, over the letter with the arrow is the direction in which it's headed. If you don't like to write it that way, and you want to write it in opposite directions, then you could write BC with the arrows going that way, and that would be an appropriate answer. But you have to have the same endpoints and make sure they're headed in opposite directions. Next problem. Okay, number 2. Line ST is 4x minus 8. TR is 2x plus 10. SR is 60. Okay, we have to draw a line here. Whoop. All right. Now we have ST, TR, and then we have SR. So we have all sorts of goodies. ST, TR, and then SR is the whole piece. So always draw a picture to start us out and plug in what we know. So we got 4x minus 8. We got 2x plus 10. And then the whole thing is 60. Now, ST and TR are not congruent to each other, at least as far as I know, so I cannot set them equal to each other. Instead, I'm going to use segment addition postulate. So we're going to go ahead and add both of the two smaller segments together and set it equal to the large segment. Now we use some algebra. This is going to be 6x plus 2 equals 60. Subtract 2 on both sides. We're going to get 6x equals 58. And then we're going to use our calculator here and divide this in. And this is not going to end up super good, but we're going to get x equals 9.6. Repeating. Or we could write that as 29, sorry, started writing the wrong number. Or we could write that as 29, come on, over 3. So either one of those two would be sufficient. Again, I'm looking for TR, so I got to plug it back in. So this is going to be 2 multiplied by 29 over 3. I'm going to use that, plus 10. So I'm going to take care of this first. Now, I have 29 over 3 in there already, so I'm just going to hit multiply by 2, and it's going to get me 58 over 3, because I'm doubling it, plus 10. And then we can put this over 1 and multiply top and bottom by 3. And now we're going to get 30 over 3 plus the 58 over 3. And we're going to go ahead and add the tops, and we're going to get 88 over 3. And if we do that, we're basically stuck, and we can leave that as our final answer. So this right here is the value of TR. Okay? Fractions are friends, not enemies. Next. Okay, so here's our third example. We have two lines, where they're straight lines, and we got to figure out what kind of angles we have. So we have 1 and 3. They're made up of the same line, so this is actually vertical lines. Vertical. Sorry, not lines, vertical angle. 1 and 2, they're right next to each other, so we could actually call these adjacent angles, or we could actually call them supplementary too. Or, since they're adjacent and supplementary, we could also call them a linear pair. And this actually works out that all of these are all 3, because 4 and 3 also form 180, also share a common vertex and a common side as one another, and so they're also a linear pair. Okay, so 1, 2, and 3 and 4, 3 are linear pairs, supplementary and adjacent. This right here, if I said 40 and 140, that would only be supplementary right here. They would not be adjacent and they would not be a linear pair. Let's go for maybe two more. Okay, so this one they want us just to find the midpoint. Okay, so we want to be very particular here. We want to label our points x1, y1, x2, y2, and then we want to write the formula. M equals x1 plus x2 over 2, and then we want y2 minus y1. Can I do that? Plus. Okay, and we want to keep consistent, so you don't want to switch these around. Okay, so like I just did. We want to go ahead and do y1 plus y2, and then divide by 2. Okay, so let's go ahead and plug in what we know. We're going to get x1 and x2, so that's going to be 4 plus 3 divided by 2. And this is going to be 5 plus a negative 7 divided by 2. That's going to be 7 divided by 2, and we're going to leave that. That's going to be 2 divided by 2, which is just 1. And there we go, our midpoint. Last one. Okay, last one here. It says given dr, d is 4, negative 10, the midpoint is 8, 5, what's r? So first step, draw a picture. Always draw a picture. And dr is given to us, and then apparently m is the midpoint. So we have 4, negative 10. M is 8, 5, and we want to find r. Okay, instead of doing the equation we did in the last one backwards, we can do accounting instead, okay? So I'm going to go ahead and let's do some different colors. I'm going to do blue for the x values, and I'll show you how we're going to get there, okay? So I count from 4 to 8. I'm adding 4 from here to here. So I'm adding 4 again. So I add 4 plus 4 is 8. 8 plus 4 is 12. And that's as simple as it needs to be. Then we can do the y's, and we're going to use green. Negative 10 to 8. So I'm at negative 10. I have to move all the way up to positive 8. So I have to move 10 units to 0 and then 8 more. So I'm adding 18 to get here, and then I'm going to add 18 more to get up to here. So 18 plus 8, what is that? 26? I believe. Let me double check. You know, Mr. Smith makes mistakes too. I double checked. Always a great math move to double check when you have a calculator, okay? Because as smart as we are, we do tend to make dumb mistakes. And that's it. That's our answer. Pa-chow, 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 pa-chow. See ya.